Welcome back, Pre-Algebra. We're in Lesson 8, and I want to talk a little bit about multiplying and dividing by powers of 10. So when we use 10 as a factor 2 times, that means simply we say 10 times 10, we get 100. The easiest way to do this is to count the zeros and put it behind 1, because we know 1 times 1 is 1. If we had 3 tens, that would be 3 zeros, right? So whenever we multiply a number times power of 10, we're effectively moving the decimal point to the right. So for instance, if I had 3, which we know has a decimal point here, and we said that times 10, we would end up with 30, which would move the decimal point from here to here. So the decimal point moves to the right the number of tens that you're multiplying by, or the number of zeros that you're multiplying by. If I multiplied the same 3 times 1,000, or that's the same thing as times 10 times 10, 3 zeros, I would have the number and 3 zeros behind it. Of course, the decimal point is behind that. So effectively, what you're doing is every time you multiply by a power of 10 or by a 1 with zeros behind it, you put these 3 zeros, or you use these 3 powers of 10 to move the decimal that many places, okay? So the same is true when we multiply a power of 10 times a decimal number. So let me see what we have. Let's do example 8.1 and clear this. In example 8.1, we are going to multiply this number times 100, which is 2 powers of 10, or 10 times 10. We don't even have to think about it. We count the number of zeros, 1, 2 zeros, and we move the decimal that many places, 1, 2. So the answer would then be these numbers, and then the decimal, and then we just count 1, 2, 3, we put our comma, 1, 2, 3, and we put our comma. So you can see that's all you're doing is you're counting the number of zeros and moving the decimal to the right that many times. So let's try 8.2. There's really not any math per se involved. That we are doing math, but it's not hard. It's what we would consider mental math. And we're going to multiply this times 10,000. So all we have to do is count the number of zeros, 1, 2, 3, 4, and move the decimal place, 1, 2, 3, 4. So our number is now 316.52. So 316 and 52 tenths would be our answer. So let's try one more. Actually, let me talk about the division of this for just a moment. When we multiply, we move the decimal to the right, right? So when we divide, the number gets smaller. So when we divide by a power of 10, we're going to move the decimal to the left. So in problem 8.3, let's look at that. We have 41.32 divided by 1,000. That is 3 places, but we're dividing this time. So instead of moving it to the right, we're going to move it to the left. 1, 2, 3 spaces. So 1, 2, one more. We've put the 0 in there to account for that other decimal space. So our answer would be 0.04132. So see how easy that is? And when you have no number here, you put a 0 in its place. So let's try one more, 8.4. So this time we're going to divide 48.512 by 10,000. So again, all we do is count the zeros, 1, 2, 3, 4, and move the decimal place to the left because it is division. 1, 1, 2, 3, 4. 4. That's where the decimal goes. We have to put a 0 here and a 0 here. So our answer is going to be 0.004851 because we divided. So remember, when you multiply by a 10 number or any number with zeros, we count the zeros, right, and then move to the right that many places, the number of places. When we divide by 10 or a number thereof with zeros, we count the zeros and move to the left that number of places. All right, and that is how we would solve these problems. We multiply, we move to the right. We divide, we move to the left. All right, so let's talk about ordering decimal numbers. Let me clear this page for us. The number line can be used to help us understand the way decimal numbers are arranged in order. If we want to order, let's say these numbers right here, 4.36, 4.22, 4.65, and 4.56. The thing to do is to look at the place value for each number. And you're going to put it in its proper order by looking at the whole number. We know these are all 4s. But we look at what comes behind the decimal and we put that in numerical order. So on the number line here, let's say this is 3, and let's say this is 4. We would put these, actually, let me change that. This is 4 and this is 5. So we would put these in numerical order in the order that they occur. So 22 is smaller than 36, and it's about a quarter of the way, so we put 4.22 here. And then that's about a third of the way, so we put it here. That'd be 4.36. And then 4.5 comes before 4.6. So that's a little over halfway, so right there would be 4.56. And then 4.6 would be right here, so 4.65. So what matters is this number right next to the decimal. If you can order it using that number with all of the numbers you have available, then that's pretty easy. But what if you have all of these numbers the same? So for instance, what if you had, let me give you a number line here. All right, this is the number 4.5. Actually, on the number line we have integers, so, and this is 5. But we know right in the middle, right, we have 4.5. What if we had 4.502, 4.518, 4.537, and 4.509? Which number would come first? This one. Because 4.5, they're all 4.5, but 0 comes before 1, right? And 02 comes before 09. So 4.502 would come first, and then you would put 4.509. So it's just like just like what you think it is. The lower the number as a whole, that's the order that you put it in. You put that first. So the next number would be 4.518, and then the next number would be 4.537, because as we go from 4.5 to 5, these numbers are actually getting bigger. They're increasing. So when you go to the right on the number line, the numbers increase, so that's the order that you put them in. But what you do is you look at the first number, then you look at the second number, then you look at the third number, then you look at the fourth number, and you just put them in the proper descending or ascending order. So 4.509, 4.518, 4.537. And you can see it's from this side to this side. From left to right is the order in which you look at them. All right, so let's put these numbers. Let me give you some numbers here. Let's see. So let's put these numbers in order. So let's look at them. First of all, we want to start with the smallest number. We want to go from least to greatest. Those are our instructions, and this is example 8.5. So I'm just going to circle them and move them around. So what is the smallest number? Well, 0 is smaller than 4 and 7. So these two are going to be the smaller numbers. But now we need, because they're the same, we need to look at the next number over and see which one is smaller. So between 4 and 7, 4 is smaller. So this is the smallest number. We're going to put that in order here. Now we know this is going to be the next smallest number because 0 is less than 4 and 7. So we can put that in order next. Now looking at this, we see that 4 is smaller than 7, so it's the next number. And then 7 is the last, 0.7 is the last number. It is the largest of all four of those numbers. So from least to greatest. And we just look at the place, which determines the place value, starting from left to right. That gives us the size or the value of that number, and it helps us to put it in the proper order given the directions. Now, your directions might say greatest to least, or they might say least to greatest. Some other keywords you want to look for when it says, oh, let me get my pen. When it says least to greatest, that is also called ascending, because it means it starts low and it goes up. It gets bigger. It ascends. Greatest to least is descending. Descending means it gets smaller. It descends. It comes down. So if it says ascending order, that means least to greatest. And if it says descending order, it means greatest to least. This one was ascending because it was climbing higher, right? It was going, ascending, like you ascend the stairs, you go up. When you descend the stairs, you go down. So that is what that means. All right, so this was an ascending activity. That is all that we have for lesson 8. I will see you all in lesson 9.